Hello, so my name is Becky O'Connor, a Solution Innovation Architect at Snowflake, and I want to talk through how I have leveraged Geospatial Analytics, Cortex, and the Route Optimization service to create a dynamic route simulator app where you can simulate deliveries to real places across any industry anywhere in the world. Now let me take you through this. Here's an outline of the solution. Cortex Complete actually plays an important role in this solution, as a user can just type in where in the world they want to base their simulation on, and all locations will be dynamically centered around that. The Route Simulator app takes on the seller specifics such as location, what types of jobs can be fulfilled, and what vehicles they may have. The customer delivery requirements takes a sample of orders based on a user-defined template per industry, as well as a sample of real locations which come from the Overture maps. We then leverage the open source project route optimization service to create jobs suited to the demand of the customer and the service availability of the supplier. We will leverage 3 APIs from the service: the ability to filter data using drive time with the isochrone API, the ability to optimize a route of drop-offs using the Optimizer API, and finally, the ability to produce directions using the Directions API. All of this will be graphically presented back to the user. Before I demonstrate the user experience, I will break down the solution. To start with, I have signed up for a free account of the Route Optimization service. Upon signing up, you will get a free token which gives you access to the APIs. Please note the API call limitations. If you have a requirement that requires more than 500 routes today, for instance, you may want to consider self-serving the open source project yourself inside a Snowpark container. This will remove all restrictions. You'll see that in the website you have the ability to test out any of the APIs. The Directions API is a nice, simple point-to-point service which provides the code to translate this into a variety of language. For this use case, we'll be using Python. Let's now look at the setup from a Snowflake perspective. Firstly, we'll get our key dataset for simulating example jobs and suppliers from the CARTO Overture maps. The Places dataset provides an updated set of points of interest locations everywhere in the world. So once we've given the correct access to the new dataset, we will create a secret, which is where the new API token from the optimization service will reside. A network rule will allow egress traffic between Snowflake and the optimization service. This will be attached to a new external access integration. Now for the functions. I first started by creating a directions function. As you can see, Python is utilized to call and return the results from the API. The response will effectively be data stored inside a variant field. Now that the directions function is created, let's test it by putting sample data inside the function prompts. The function requires a method, a to location, and a destination location. So this function has now generated a set of coordinates which represents the route. Let's have a look and see what this looks like graphically using PyDeck Geospatial Visualization Library. So now it's rendered, you can see that this is a very simple example of one of the service's APIs. Let's create a slightly more sophisticated function, this time by calling the API which creates a route with multiple drop-offs. This API will require a single array containing multiple destinations. The Directions API will effectively join all the dots up in order to form a line which takes into account valid routes for the intended vehicle. To test it out, we will need to specify an array of latitude and longitude coordinates. The driving car again is used for the method. We can see again that we get an array of coordinates again, but this time taking into account multiple waypoints. Again, let's have a look and see what this looks like on a map by using PyDeck. You will see that the return map clearly shows that we are not going from start to destination at its most direct form. We could have overlaid the map with all the drop-off locations to see this more clearly. We will do this more within the app itself. The next function we'll create is the optimization function. This requires 2 arrays to be sent to the service. an array of jobs, which is the customer demand, followed by an array of vehicles, which is what the supplier has to meet the demand. Each array has conditions such as start and end time and when the job is needed. Now for the isochrone function. This function will be used to filter sample jobs based on drive time. Upon inputting the latitude and longitude and drive time in minutes, the service will return a catchment polygon. I've now tested this function, this time by creating a polygon based on cycle time of 20 minutes within Paris. Let's have a look what this looks like visually. Again, I've used PyDeck for this effect. So I can now imagine myself as a cyclist. If I were parked in the center of the blue polygon, I would be able to reach anywhere inside this boundary within 20 minutes. All these functions are now readily available for the new application subject to privileges. Let's now create the base data for the simulator. Firstly, I created a generic job template consisting of 29 jobs. The specifics will be populated dynamically when the user chooses the industry and location. You will note that there are some columns which are relevant for the optimization service to work, such as slot start, slot end, and skills. These represent customer requirements for each job. After previewing the job templated table, we will now create a point of interest base table which has come from the CARTO Overture maps. To increase performance, I have performed some light transformations in SQL as well as switching and optimization for an array of point of interest categories and geometries. This will be using the search function to retrieve only relevant information for industry. So there we have it, optimized data for all points of interest all over the world. Let's now test this dataset with our isochrone polygon of Paris, which we created earlier in the notebook. We are leveraging ST-within to only achieve data which fits inside my 20 minutes possible cycle ride. ST-within is a native Snowflake geospatial function. This combined with search optimization filters the data within seconds. Now we will use PyDeck to visualize the results. Upon running the function, you'll see all of the hotels that I can go to within a 20-minute cycle ride time from the center of Paris. So zooming in will make the hotel locations a lot clearer. We could have added tooltips to aid the visual. This will be achieved later within the app itself. Let's now have a look at the search feature which we used in the app. I want to search for all distinct point of interest categories that contain the word food. So we have now retrieved a list of categories which both feature in the categories column, which is a string, as well as a list of alternative categories, which is an array. We now need to create a way of dynamically applying the industry selector for the application. This is achieved by creating a new table for the industries as well as key attributes for products, sample customer types, and types of point of interest categories. This example only features 3 industries, but here you can have the ability to create more as you require them. As you can see, the lookup table will create a row of data per industry, with all details stored as strings or arrays. We will now test our industry lookup with the healthcare industry, which will give variables needed to generate jobs for flammable products. We have now got all the standing data and functions needed for the app. Once assigning the correct privileges, let's now have a look at what the Streamlit application looks like. The user has populated the desired industry as healthcare and the location in which they want to generate a simulation, which is 5 kilometers of Heathrow Airport. Upon zooming in, we can see the types of suppliers that we can use within that location. Hovering over gives me more information about each potential distributor. Again, all of this is real data. The selector allows me to choose a supplier I want to base the route optimization simulator on. We will now select the types of customers for our job deliveries. If you remember, the categories came from the industry lookup table. Now it's time to configure our available vehicles. The application assumes 3 vehicles for any type for each simulator. You can, however, change the start time, the end time, and the method for each one. Well, this example, I'm going to make a slight modification to the start time, and also the method in vehicle 3 is actually going to be an electric bicycle. So now I press the job route button. This will then do the following. Run the isochrone API to filter the POI data based on order catchment time. Run the optimization service to discover the best plan for each vehicle. And finally, run the directions service to visualize all routes on a map. The list of jobs has been created based on a sample of points of interest relevant to the industry and location selected. I've color-coded each vehicle consistently using Streamlit CSS capabilities. Let's now have a look at what this looks like on a map. All 3 vehicles have each of their jobs allocated. You can see that vehicle 3 has 4 jobs. Interesting that this vehicle has the longest duration, probably because the vehicle is in fact an electric-powered bicycle, significantly slower than a car. The application allows the user to explore the vehicle route plans in isolation. The Directions API not only produces the line strings for each route, it also gives clear directions written in natural language. We will now run another simulation, this time for a different industry and place. Cortex Complete will attempt to provide approximate coordinates of any place in the world. In this case, we will search for food distributors within New York City. Again, same as before, we can now scroll to view a map of all the distributors within a 5-kilometer distance of New York City. One of these we will actually pick as our route optimization distributor. I will pick from a list of distributors in order of distance. This time, I think I might choose HelloFresh. Now for the customer type. Again, only relevant types of customers are displayed. I will select supermarkets and restaurants. After pressing Get Job Routes, I am now presented with the sample jobs for supermarkets and restaurants to be supplied by HelloFresh in New York. And as before, each vehicle route is presented on a map, this time in New York with real-life drop-off areas. Let's observe the unique direction simulation plan for each individual vehicle. You will note that every drop-off is separated by a segment, which will also include the return journey back to each depot. Now we are going to simulate route optimization plans for a cosmetic distributor in Orlando. You can see that we have rather a long list of potential cosmetic suppliers within a relatively small area of Orlando. After choosing customer types of supermarkets, fashion and outlets, we are presented with relevant sample jobs. And as we scroll down to view the map, as before, the map features drop-off points and directions for all 3 vehicles, but this time they are in Orlando. So now let's get into the mechanics of the app itself by focusing on the Streamlit Python code. As a Streamlit developer, I have quick access to edit mode by simply pressing the edit button within the UI. This, of course, will only be available to users with the correct privileges. The first thing I want to highlight is the way we are bringing that lookup table we created previously into the Streamlit app by simply using the session.table function. Once available, this can be used to drive variables and input widgets such as the ones we saw in the sidebar. The job template and industry will be dynamically changed with the parameters driven by that table, which are then defined with additional variables. Let's have a look at the point of interest table. This was the search optimized table which we created earlier. We are selecting key pieces of information by using Snowpark data frames. The function here is using a Cortex large language model to retrieve the latitude, longitude, and distance, which enables simulation modeling anywhere in the world. Here we are using the text-based search function to narrow down all the category words by industry type. This is after leveraging the Geospatial st-within function to narrow down the location. Remember our industry keyword setup in the industry lookup table. This example will search for food types, then we'll search for the distributor type. This is why the search was featured twice in the code. And going back to Streamlit, this is where the job template is presented. The first custom Snowflake function is declared here. This is to filter the potential job locations by generated isochrone polygons. Next, we bring all the job and vehicle data into the route optimization function. Finally, we run the directions function in order to return directions for each package drop, which can then be easily presented on a map. The PyDate library feature is used the same way as you saw in the code earlier. This time, though, parameterized to make the app as dynamic as possible. So whether you decide to simulate routes in Frankfurt or Tokyo, or even if you feel adventurous by trying out routes within the French Alps, the route optimization simulator is dynamic enough to cater for a whole range of scenarios. And remember, all of this can be powered by Snowflake. It is even possible to create a Snowpark container which contains the optimization service in Snowflake, allowing full control, no restrictions, with all data never leaving Snowflake. So this is the end of the dynamic route optimization demonstration, and I really hope you've enjoyed it. All the code is fully available for you to try out and test as you see fit. And you might also use the code as a template for real-world routing use cases as well. So I hope you've enjoyed it. Thank you very much for listening.